Section 2, the structure of DNA. All right, I'm going to give you an easy way to understand how DNA should be thought of. DNA, we're going to think about it in three basic components. First, we have a sugar, 2'-deoxyribose. Ribose is a sugar. It's a pentose. If it's a pentose, how many carbons does it have? Penta means 5, so it's a 5-carbon sugar. And here's ribose. We have our 5 carbons here. We label our carbons in these sugars. Over here, we're going to call that the 1' carbon, the 2' carbon, the 3' carbon, the 4' carbon, and up here the 5' carbon. And while I don't want you to memorize lots and lots and lots of chemical structures, I do want you to know the carbons in ribose here, because they're pretty important. We're going to get to know these 1', 2', 3', 4', and 5'. A sugar should have a hydroxyl at every carbon, but this one doesn't. Instead of having hydroxyl, it's got no oxygen there, it's deoxy at the 2' position. So it is 2' deoxyribose. That's our sugar. Got that one? Good, that's the first part. Next, in thinking about DNA, we have a base. The base, now I'm going to simplify our sugar just down to this. The base hangs off the 1' carbon. That's where the base goes. And the bases come, there are 4 types of bases, and the bases are, two of them are a 6-membered ring and a 5-membered ring, 6 and a 5, and one of them has a 6-membered ring. Sorry, two of them have, sorry, 2 have this and 2 have this. These guys are purines. These guys are called pyrimidines. The 2 purines are adenine and guanine. A's, G, we write. These guys here are thymine and cytosine. T and C. Those are the 4 possibilities for the base. And these structures involve carbon, nitrogen, oxygen, hydrogen, and they're not that all interesting. It's not like the amino acids that have positives and negatives and hydrophilics and hydrophobics and all the, and cysteines with a sulfur sticking out. They're pretty boring. That's it. So we have a sugar, and on the 1' carbon, one of 4 choices of bases can be put. Now, see, on this sugar, with our base hanging off here, off this 5' carbon, I want you to see triphosphate. A triphosphate hanging off. Triphosphate. Okay, there's our, let's see there, triphosphate. That's it. That's our building block. This guy is called, the whole thing is called a nucleotide. With the sugar, the base hanging off the 1' and the triphosphate hanging off the 5'. That's it. That's our building block for DNA. Now, how do we combine these building blocks to make a chain of DNA? Well, we polymerize them by a dehydration synthesis. So if we have over here our sugar, our base, our carbon over here, we have going from the 5' carbon, we're going to connect, breaking that triphosphate and using the energy to do that, to the 3' carbon of our next sugar. Another base here. And so we have our base hanging off the 1'. We're going to connect from this 3', sorry, this 5' to this 3'. That's the connection that's made. Is this 3' is connected to 5', this 5' connected to this 3'. So now we're using a lot of these guys here. 5', 1' are getting used over here. And what was special was that this guy here was deoxy, the 2' position. Now, I can keep going, because if I have another phosphate there, I can attach. I can have phosphates coming down here. And in fact, what I have is a backbone, a structure that goes sugar, phosphate, sugar, phosphate, sugar, phosphate, sugar, phosphate. And that's it. It's just an absolutely boring chain of sugar phosphate, except for bases hanging off it. And the bases only come in 4 flavors, and the 4 flavors are not that all chemically different from each other. To make sure you're following this lecture, test yourself with this question about the building blocks of DNA.